Hi, my name is Jane Hill, and this is a lab report for the second lab of Physics 2212. The purpose of this lab was to continue exploring the concepts related to the electric charge using everyday objects. Electric charge is a property of matter that causes objects to experience a charge when placed in an electromagnetic field. Using the data we collected in lab 1, we will create a computer model that proves that the experimental charge across a tape using a point charge is the same as the experimental charge is the same as a charge using the tape as a whole. With this program, we are trying to prove that the charge we found in lab 1 was the correct amount of charge. For this program, instead of assuming the tape was one point charge, we are assuming it is made of many individual charges. Okay, so the first part of the program is just setting up the constants we're going to be using for the problem. So Phys is Coulomb's constant, G is the gravitational constant, M is the mass we calculated from the first part experiment, but it's in kilograms. So and Q is the charge we calculated in the first part experiment. Below it is the electrical field function that we created in lab 0. It calculates the electric force on a charged particle between two charged particles. This next part essentially creates the pieces of tape. So this first part is the line charge function creates a series of uniform point charges that, given the total charge Q, divides them equally and allows you to know which on the axis of the tape how many charges you need and how much they're worth. The second part, called creating tapes, physically makes the lines so you can see them, which you'll see in the result slide. The top piece of tape is located 0.005 meters above the bottom tape because that is how much we measured in our initial lab. We also have the length of each tape, which is we measured to be 19 centimeters here, so you can see that's 0.19, and that helps define the axis of the tapes. The next part does the calculations for the electric force, the electric field, and the gravitational field, essentially making the arrows. So going to lines that we edited, first we had to find a scaling so we can see. To find the scaling, I mostly guessed and checked, as well as to change the function so that the electric force on the top due to the bottom had the correct value. As you can see, the for loops make it so that each point charge has their own electric field arrow. So you can see the entire electric field, which you'll see in green. Finishes up everything that you saw in the previous part. So you calculate the final electric fields, and then this part creates the arrows. So at the bottom it prints the magnitude of the electric force and the gravitational force, and then the white arrow that you'll see in the next slide is the electric force, and then the yellow arrow is the gravitational force. You saw on the previous slide, the value of the electric force that we got was greater than our estimated value of electric force from our previous lab, meaning our estimated electric charge was smaller than what it should have been. This could have been done to user error or computational errors when we did the original lab, but the percentage that the difference wasn't that big. Therefore, they're both roughly equal to roughly 1.5 newtons, meaning the charge wasn't that off. The more accurate data was more than likely the computer model, just because of the lack of human variation in it. Thanks for watching.